Hello everyone, my name is Siri. I am from the department ECE and today my topic is about transformer. In this video presentation, I will be explaining about the transformer. I will cover its definition, construction, working principle, types and applications. So, introduction. A transformer is a static electrical device that transfers the electrical energy between two or more circuits through electromagnetic induction. It does not have any rotating parts and works only with alternating current. The main purpose of a transformer is to increase or decrease the voltage levels while keeping the frequency constant. The ability make the transformer an essential component in power transmission and distribution. Electric power generated at power stations cannot be transmitted directly at low voltage because it causes huge power loss. Therefore, voltage must be increased for long distance transmission and then decreased before supplying to home and industries. This voltage conversion is made possible by transformers, making them an integral part of the electric network. For example, the small black adapter used to charge a mobile phone relies on a miniature transformer to reduce the mains voltage to a safe level. Working principle. A transformer works on the principle of mutual induction where a changing magnetic flux produced by alternating current in the primary winding induces a voltage in the secondary winding. When AC voltage is applied to the primary winding, it produces alternating magnet flux in the core. This flux links with secondary winding resulting in an induced voltage. If the secondary winding is connected to a load, current begins to flow, transferring power to the load. The ratio of voltages depends on the number of turns in the primary and secondary windings. This is known as the turns ratio. For example, if the secondary windings has more turns than the primary, the transformer becomes a step-up transformer. An everyday example is a transformer inside a laptop charger which increases or decreases voltage based on the laptop's requirement. For instance, power distribution transformers seen on electric poles contain oil-filled tanks for cooling. Transformer core. The core is usually made of thin laminated silicon steel sheets. Laminations are used to reduce eddy current losses. The purpose of the core is to provide a closed magnetic path for flux. Primary winding. This is the coil connected to the input supply when AC voltage flows through it. A magnetic flux is produced in the core. And secondary winding. This coil is connected to the load. The induced EMF generated in the winding supplies power to the connected device or system. Insulation. All windings are insulated using varnish or paper to avoid short circuit between coils. Tank and cooling system. For large transformer. Large transformer powers contain insulating oil for cooling and to prevent overheating. Radiators, fans or pumps may also be used. Each part works together to ensure efficient magnetic coupling between the primary and secondary windings. Transformer can be step-up, step-down or isolation transformers based on voltage transformation, and they can be single-phase or three-phase based on the power supply system. A step-up transformer is used in power stations to increase voltage for long-distance transmission, while a step-down transformer lowers voltage from home use from 11 kilowatts to 230 volts in distribution. Transformers are classified based on various criteria. Based on voltage conversion, converts low voltage to high voltage used in power stations. Step down transformer converts high voltage to low voltage used in distribution networks, chargers and appliances. Based on construction, core type transformer windings are placed around the core limbs. Shell type transformer core surrounds the windings from three sides and provides better efficiency. Based on the application, power transformers used in transmission networks for high voltages, distribution transformers used near residential areas for low voltage supply, isolation transformers provide electrical isolation for safety. Instrument transformers such as CT current transformer and PT potential transformer used for measurement and protection. EMF equation. The EMF induced in a transformer is given by the equation, meaning the induced voltage depends on the supply frequency, the number of turns and the magnetic flux. For example, doubling the number of turns in the coil will approximately double the output voltage. Efficiency of a transformer. The efficiency of a transformer is the ratio of output power to input power, and it often ranges from 95% to 99%. An example is the power grid distribution transformer, which is designed to operate at peak efficiency around its rated load to minimize energy waste. Cooling methods. Transformers use different cooling methods such as air natural, oil natural air natural, and oil natural air forced cooling. For example, large substation transformers often use radiator fins and cooling fans to manage heat during heavy load conditions. Applications of a transformer. Transformers are used in power transmission and distribution, voltage regulation, audio systems, welding machines, and electronic devices, power generation, transmissions, and distribution systems. Household appliances like adapter chargers, audio systems and amplifiers, voltage stabilizers and UPS systems, industrial machinery, electric furnaces and welding machines, communication systems, measuring devices like CTS and PTS. Advantages. Transformers play a critical role in enabling long distance power transmission with minimal loss. They ensure the electricity is supplied safely, efficiently, and the correct voltage level for homes, industries, and commercial uses. Without transformers, modern power systems would not function efficiently. For example, a well-maintained distribution transformer can be operated continuously for decades with little need for repairs. Conclusion. To conclude, the transformer is a highly efficient and essential device in electrical engineering. It works on electromagnetic induction and enables voltage conversion for safe and effective power distribution. Understanding its construction, working, and types is important for every ECE student, as transformers form the backbone of power systems. And examples such as mobile chargers, power grids, transformers, and electronic devices show how vital they are in a daily life. Thank you.